Hello, and welcome to How to Make a Path of Exile to Trade Tool with some help from AI. My name is Max, and I've been building software for about 20 years now. I've worked at Apple, I worked for the government, and I worked at a startup that eventually grew to be worth $1 billion. Despite being a deeply lazy person at my core, I have over the years learned a thing or two about building software, and I want to share that with you in this course. I'm a longtime enjoyer of Path of Exile, and I've always kind of wondered how the trade tools worked under the hood, so when Path of Exile 2 came out, I decided to make one. It's called Chiseled. You can find it on GitHub if you want to check that out. And in this course, we're going to build a slimmed down version of this app from scratch together. The very first thing that I want to talk about is exactly how we're going to be using AI. And that's just because there's so much hype surrounding AI right now. And don't get me wrong, I do think it is an incredible tool. But let's be real, it absolutely does have its limits. So I made this kind of crazy looking diagram to cover reliance on AI as it relates to efficiency, required skill, and control. Let's say that we're building our app and we're taking an approach that's somewhere on the right side of this range here. AI does everything. It's very efficient. We don't have to make a ton of design decisions. We don't have to write a bunch of code. And it's very beginner friendly. We love that. But we have almost no control over the outcomes. And when you don't need a lot of control, this is awesome. You know, when it works, it works. But as soon as you do need just a little bit more control, it can be really frustrating. And maybe you've experienced this where you're trying to build something with AI and you have an idea in your head of what you want. You're trying to communicate that and it's just not getting it. You're kind of banging your head against the wall. And at some point you're like, man, this would actually be easier if I just did it myself. So now let's talk about what that side of the range looks like, where you do everything yourself. Now it's very inefficient. You are making all the decisions. You are writing all the code. It's kind of tedious. You do have to be an expert in a whole bunch of different concepts. But the upside is now you have total control over the outcomes. So I'm going to call this side of the range hard mode, and I'm going to call this side of the range slop. And I'm going to argue that the sweet spot is somewhere in the middle here. There's a bunch of stuff that we're going to be doing without any help from AI at all, especially early on. We're going to be doing all of our own design work. And that's for two reasons. The first reason is that, at least right now, AI is not very good at that stuff. And the second reason is that it'll be good for us to have a super clear picture of what we want our app to do and how we want it to be structured. We want to kind of just steer AI in the right direction. And the best way to do that is if we have a really good sense of where we want to go. And once the design work is done, we'll still have to kind of keep an eye on things. For example, if you're somebody that is a little bit intimidated at the idea of writing code, the good news is AI is going to write most of the code for us. The catch is that we absolutely will have to review every single line of code that it suggests, or it will try to sneak some garbage in there. And by the end of it, we'll have landed somewhere in the middle here on our overall reliance on AI. We'll kind of split the difference on efficiency. There will be some things that we're good at, some things that AI is good at as far as required skill, and we'll land somewhere in the middle on control. So if we have an idea in our head of what we want our app to be, we'll be able to impart that without being completely reliant on whatever AI comes up with. And you might be looking at this and saying, hey, actually, I'm a beginner and this part of the range is inaccessible to me. And in that case, I'd say right now is a great time to be a beginner. AI is an amazing tool for learning. And in this course, we're going to cover the set of skills that you would need to go from this side of the range to somewhere in the sweet spot here. So what exactly is a Path of Exile trade tool? Well, Path of Exile is a game where you run around slaying demons and hopefully get some equipment that can make your character stronger. So one thing that comes up is you get some loot and you're wondering, is this worth anything? And Path of Exile has an economy, so you can trade items to other players, but it's not always obvious what an item is worth. So one way you could determine that is you could go to the trade site and you could start to fill out this form. You could say, oh, well, they're boots and they had some movement speed on them. And there was also some lightning resistance on there. And you could search. But this kind of sucks. This is kind of tedious. I don't want to tab out of my video game to fill out a form. So wouldn't it be better if we could just hover over the item, press a hotkey, and immediately have all that populated for us? So now we can just click around a little bit and search for similar items this way and get an idea of what the value of that item is. So this is what we'll be building. This is a Path of Exile trade tool. So here's an overview of the course from here on out. This entire course is 1 hour long, meaning each step is about a few minutes long. So let's skim through this real quick. We come up with a design, we get our tools in order, we use AI to make a prototype, we take a look at how the trade site works, We use AI to integrate with the TradeSite API. We use AI to fix a bug. We clean things up a bit. We go back to the trade site. We use AI to support lots more item stats dynamically. We talk about tests. We use AI to wire up a hotkey. We use some design patterns. And then we deploy our app to GitHub and we set up auto updates. Okay, so stepping back for a sec, you can see that we're using AI to do a lot of the heavy lifting, but there's still a lot of things that we're doing ourselves. And the general pattern is that we do some manual legwork to understand our problem, and then we use that in our AI prompt to get a better result. And then after all that, we're usually going to come in and manually clean things up a bit. And I want to be upfront. If you are a total beginner, this is going to be a lot of new stuff getting thrown at you. I am going to show you every single step. I'm not doing anything off camera, but this isn't really like a beginner tutorial on Rust or Tauri or Git. However, you are going to see exactly how this stuff is used in practice to build a trade tool. And my hope is that even if you are a total beginner, this can show you the overall process of building and delivering software, which is what I personally think is the important part. Let's go ahead and whip up an architecture diagram. I'm in a tool right now called Lucidchart. It's free. It's what I'm used to. It's just a diagramming tool. You can use any diagramming tool. Basically, we just need to draw out some boxes and arrows. So I pulled in a screenshot here of Path of Exile, and we're going to think about the flow of our trade tool. So somebody's playing Path of Exile, they find an item, they hover over it, and they press the hotkey. So hotkey pressed. And now we've got some work to do. So we need to convert the item details into a list of trade site filters. And we'll give that a color. And once we've got the trade site filters, we need to show those to the user so that they can pick and choose what they want. So here we'll say pop-up front end, and we'll block out the front end. Give it a color as well, we'll say teal. And now we've got some trade site filters, and let's say item type of boots with some movement speed and some lightning resistance. And we'll format this guy, stick it there. And our app will also have a search button for them to press. So put that there. And we'll say search pressed. And now we've got some more work to do. So here we'll say search p.o.e trade site for selected trade site filters. All right. And this part's actually an external request, right? We got to go out to the internet, see what exactly is on the p.o.e trade site. We'll say purple. And then we'll have some results to show to the user. So say search result. And there might be a couple of them, so drag out a couple. And this one will be return results. Cool. And since we showed the boundary of the front end, let's go ahead and do the same for the back end. Give it a color, send it back. And just like that, without too much work, we've got an architecture diagram. And just to be transparent, I'd say this isn't a typical architecture diagram. Technically, this is more like an architecture diagram blended with a mock and a call graph, but none of that's really important. I'd say that the important thing is that we started with some ideas in our head and we fleshed them out to the point that it more closely resembles like a blueprint or a plan. And now we can start writing some code. Let's get our tools in order. I'm in an app right now called Cursor. Cursor has a free trial, but if you use it enough, it will eventually start asking for money. And Cursor is an AI code editor. What that means is that it's built to streamline the process of writing code with an AI model. So on the right-hand side here, we've got this chat panel, and this is how we'll prompt AI. And if I click around a little bit, there's a handful of models we can choose from. I've got Claude 3.7 Sonnet selected. And another tool we'll need to consider is which Windows desktop framework we're going to use. We're going to be using Tauri. And let's go ahead and recap on some of these tools. We're using an AI code editor called Cursor. Some alternatives are Windsurf, RuCode, and Klein. We're using an AI model called Claude. Some alternatives are Gemini and GPT. And we're using a Windows desktop framework called Tauri. Some alternatives are Electron, Qt, and Flutter. And I've noticed that there's pretty fierce debate online about which one of these is the best in each category. And it can kind of lead to like decision paralysis where you feel like you need to research all of these different things and make the best decision before you can get started. But I want you to know that you could use any combination of any one of these alternatives, and the overall process that we're going to be following will remain exactly the same. Any one of these tools is totally fit to build our trade tool with. To get started with Tauri, we could totally ask Claude to whip us up a template, but the problem with that is that if it doesn't work, it's going to be pretty difficult to troubleshoot exactly where it went wrong. So I'm going to suggest we do one more thing without any help from AI, and that's to follow the Tauri Quick Start. So I'm here on Tauri's homepage. They've got a Get Started link, and this is the authoritative way to get started with Tauri. So this is just a smart thing for us to do. Scrolling down to prerequisites, system dependencies, Windows 7 and later, that's us. And there's a handful of things that they'd like us to download and install, starting with Microsoft C++ build tools. We can download and install that here. Next up is WebView 2. They'd like us to install the Evergreen Bootstrapper. Next up is Rust. We can download and install that here. And finally, we installed Node.js. We can skip this section on configuring for mobile targets since we're building a desktop app, not a mobile app. And there's even a troubleshooting section. And continuing on, they've got a PowerShell command that they'd like us to run. So let's go ahead and pull up our terminal and paste that in there. It wants a project name. We'll just say app. This is basically just a folder name. Identifier, we'll say chiseled course. Which language for the front end? We'll say TypeScript and JavaScript. Package manager, we'll do NPM. UI template is svelte. UI flavor is TypeScript. And what that did is that gave us all of this source code to get us started. So let's keep cruising on this quick start. Start the development server. They'd like us to move into the app folder, install some dependencies, and then start up our app. So let's go ahead and do that. All right, that was our dependencies. Now let's run our app. And hey, just like that, we've got a running, working Windows desktop app. So this is great because it tells us that all those dependencies that we installed were all installed correctly. It tells us that the source code we got set up with is configured correctly. And instead of starting from scratch, we can adapt this quick start into our trade tool. It's going to be a great way to get started. And now that we've got some source code, let's also install some extensions. So we go to File, Preferences, Extensions. And if I click the recommended section here, we've got some options. We're going to pick up the Rust Analyzer and the Svelte for VS Code extensions. And this is going to make editing Rust files and Svelte files just a little bit better of an experience. And there's one more thing we need to install, and that's Git. Git is going to let us take checkpoints of our source code as we go. And it's also going to help us deploy our app to GitHub. So I'm here on Git's homepage. There's a download for Windows link. If you download and install that, then we'll be able to type git init and git add period. That says go ahead and start tracking all of these files for changes. And then if we want to make our first checkpoint, we'll say git commit -m and we'll say Tauri quick start done. And now if we screw something up and we need to go back to this moment in time, we can do so with Git. Time to make a prototype. Let's think back to our architecture diagram, and I'm going to suggest we make one change. Instead of having this hotkey feature where we press a hotkey and the item details are sent to the backend automatically, instead, let's just stick an input box on the front end, and we'll say item text goes here. This becomes provided item text. We'll connect this up. This one becomes return trade site filters. And we will come back and set up the hotkey feature later on, but for now, just for the sake of our prototype, this will let us keep things simple. And at this point, you might be wondering, what is item text and where does it come from? Well, Path of Exile has a built-in feature where we can get the text representation of any item just by hovering over it, pressing Control-C, and the item text is put on our clipboard. Then we just Control-V and we can take a look at it. We'll get into parsing all this stuff later on in the course, but for now, that's what it is and that's where it comes from. All right, it's time to put Claude to work. We're going to take our design and turn it into a step-by-step for Claude to follow in this prompt. It's going to be kind of a big one. So we'll say, hey, Claude, I'm building a Path of Exile to trade tool. I completed the Tauri quick start as a starting point. Could you adapt what we have into a prototype with the following flow? Step 1. User provides item text in an input on the front end. 2, item text converted into trade site filters on the back end. 3, user selects which trade site filters they want on the front end. 4, User presses the search button on the front end. 5, p.o.e. trade site searched for selected filters on the back end. 6, matching items returned to the front end. Okay, let's see what it comes up with. Here it's asking to run our app. I'm going to say no for now. So now we got to review some code. And you might be saying, dude, I don't know Svelte, I don't know TypeScript, and I don't know Rust. So how am I supposed to review this code? And the good news is, I don't think it matters. It'll help if you're already familiar with this stuff for sure. But the cool thing is, this is a way that you can jump in as a beginner and learn these programming languages over time. And this is nothing fancy. We're going to be looking at one small block of code at a time. We're going to figure out what that block of code is doing. And as we go, we're going to think about how all of these small blocks are connected. And keep in mind that when you're learning, you can ask your AI assistant to explain any piece of code that you're trying to make sense of. Just remember the AI can be wrong. So this can be a super helpful tool for learning, but just be ready to verify whatever answer you get. Okay, let's do this review. The first block of code that we're going to look at is this new function called parse item text. And you'll notice that it's using something called invoke. If we hover over that, it says sends a message to the back end. So we're sending item text from the front end to a function on the back end called parse item text. Sounds good? And we'll look at the next function, search items. This one is almost identical, also using invoke, but this time it's sending selected filters from the front end to a function on the back end called search trade site. So far, so good. Here's some helper functions, toggle filter and is filter selected. These red squiggles mean that we have some TypeScript errors. We're not going to sweat those for now. And here we're removing a lot of code. So we're removing a Vite logo, Tauri logo, SvelteKill logo. And if you remember back to when we ran our Tauri quick start, this is what we saw. So we're adapting our Tauri quick start into our p.o.e. trade tool. Cool. And here we have an input element where we can put some item text. Next to that is a button, which when clicked will call that function that we looked at earlier, parse item text. So now we're getting an idea of how all this stuff is wired together. So here's where we display and can select our trade site filters. Next to that is another button, which when clicked calls the other function we looked at together, search items. And finally, we display the search results. And the rest of the stuff in this file is kind of just style stuff. So like font size, font color, stuff like that. We'll make this pretty later, but for the sake of our prototype, we don't really care that much. And now let's take a look at our Rust backend. So we've got some more squiggles. If we hover over that, it says unused import. Imports and dependencies are something that current models kind of struggle with. So if our editor is saying we don't need these, I'm just going to delete them. And here we have our structs. So this is the shape of the objects that we're going to be working with. And it's decided on the name item filter. We've been calling them trade site filters throughout the course so far. So I'm going to go ahead and rename this real quick. And it might seem like a small thing, but updating the names as you go can go a long ways towards making this code more maintainable over time. And next up, we're going to look at this backend function parse item text. So we saw this referenced on the front end. We saw that we're sending item text from the front end to this function on the back end. And now we can see what it's doing. So it's going line by line, looking at that item text. And if it finds something like item level on a line, it will parse that line into a trade site filter for item level. And the same thing goes for rarity here as well. So we've got a bit of a starting point for parsing the item text. That's cool. And here's our other backend function, search trade site. We saw this one referenced in the front end as well. We've got another squiggle. This time it says unused variable filters. That's kind of suspicious. We're not even using the filters that we passed in here. And this says simulate a delay to mimic network request. So we're not even actually making a network request. We're not actually making a real call to the p.o.e. trade site. Instead, we're pausing the app for 1,000 milliseconds to simulate a network request and then returning back some dummy data called mock results. I think it's kind of silly to pause our application artificially, so I'm going to delete that. And the next thing that we do after this change is we'll wire this up to call the real p.o.e. trade site, but for now, this is fine. And down here, we can see our Rust run function. This is pretty close to the starting point for a Rust application. And if we hover over generate handler, it says creates a handler that allows commands to be called from JavaScript with invoke. Great, that's totally consistent with everything that we've seen so far and explains how all of this is glued up. This greet command is a holdover from our quick start, so we're going to go ahead and remove that. And let's move over to our cargo file. The cargo file is all about managing Rust dependencies, and Claude thinks that we need to add 2 new dependencies. But when we were reviewing, we saw that we're not actually using request, and toke.io is just being used for that 1,000 millisecond artificial pause, so we'll delete those. And finally, we'll take a look at this README file. So this one's kind of weird because we didn't ask for a README, we just asked for a prototype. And this is another quirk of some of the current models is that they can be a little bit over-eager, and so sometimes they'll recommend things that we didn't ask for. And in this case, we're just going to say reject file. All right, now let's run it. We'll move into the app folder and do npm run Tauri dev. And would you look at that? We've got our running trade tool prototype. I happen to have some item text here. I'll paste that in. These are the boots that we've been working with so far. And we've got a handful of trade site filters. So it's got named twice here, and it looks like it didn't pick up our movement speed or the life regen. But this is absolutely incremental progress. This is cool. And then we'll click search trade site. We'll see that dummy data returned back. Cool. So this thing is pretty ugly, and there's a few parsing issues, and it's not actually searching the real p.o.e. trade site. But other than that, not bad. We had to fix a few minor things, but overall, Claude has been a huge help. So I'm going to go ahead and make another git checkpoint, and we'll call this one prototype done. And now we'll move on to making it search the trade site for real. So now we're back on the Path of Exile 2 trade site, and I've got a trick to show you. We're going to start to fill out this form based on the item text of the boots that we've been working with, which were rare and item level of 33. With some evasion on there and a rune socket, as well as some movement speed, some lightning resistance, and some life regen. But before we hit search, we're going to click the three dots in Chrome, more tools, and developer tools. And this is going to show us the network activity for any website. And we're going to use that network activity to build a better prompt. So now we're ready to hit search on the form, and we see some network activity. If we click on this first one, headers, we'll see we have a request URL. We'll save that for later, as well as a request method, post. And under payload, if we start clicking around, we'll see stuff that we entered into this form. So when this form is submitted, this is the network activity that gets transferred. And if we click view source, we'll get a format that we can easily copy for later. And if we click on response, we'll see we got an ID back, as well as a bunch of GUIDs under a heading called result. So we'll save all of this for later as well. And now let's take a look at this second request. This time the request URL is much longer, and we can see we've got all of these GUIDs separated by commas. And at the end here, we've got query and realm. Because the request method on this one is a GET, the payload is actually included in the URL. So we'll copy all this for later, come over to response, and here we can see the GUIDs that we put in the URL. We're getting more details about those results. For example, when the item was listed, the account name, the price, and some more details about the item. So we'll save all of this for later as well. And now we've got some really good context to include in our prompt. But before we do our prompt, I have a quick tip for you. If we go to File, Preferences, Cursor Settings, click on Rules, come down to Project Rules. I'm going to click Add Rule, and we'll call this Rust Quality. And under Rule Type, we'll say Auto Attached to Rust Files. And this will be from the app source Tauri folder, run cargo clippy and resolve any issues. And if you remember back to our last code review, there are a bunch of little squiggles indicating problems with our code. And cargo clippy is a command that can find problems like that in Rust files. And what this rule does is we're asking our AI assistant to try to find and resolve those issues automatically. So I'm going to make another one for svelte real quick, attached to svelte files. This time from the app folder, the command is npm run check. And these won't work all the time, but it should help. And now we're ready to start our prompt. Let's make this a little bigger, and we'll say update lib.rs to search the Path of Exile to trade site instead of returning mock results. I filled out the trade site form based on the item text below and captured the network activity as an example of how the trade site works. Make sure to also update our item text parsing to support the new filters. And now we'll just start giving it some data. So item text, we have that, and the request URL, request method was post, payload, and response, and the next request URL. And that one's method was a GET, and the response, boom. Okay, now let's see what Claude comes up with. And now we got some more code to review. Looks like we got a bunch of new structs, which makes sense, right? We gave Claude a bunch of data and it figured out the shape of all of this stuff. And I've noticed that if you can provide examples like that, AI is pretty good at this kind of thing. And this part's interesting. We've got a mapping of things like increased movement speed to the trade set ID that we saw in the query on the payload. Path of Exile has hundreds of these stats, and so we'll need to beef this up later, but for now, this works. And in our parse item text function, we can already see that we got some new stuff. Looks like we replaced most of the old parsing logic, but the new stuff follows a pretty similar pattern. And this item category mapping is interesting. So it recognizes that when it says boots on the item text, it needs to translate that to armor.boots in the query of the payload. But I don't know where it got the rest of this data from. So I'm a little suspicious that this is incorrect, but it looks okay. So let's keep it for now. And finally, all the stuff that we parsed from the item text will end up as trade site filters. And here you can see we're removing the old search trade site function with the mock results. And here we got a new function, build trade query. And this looks like the query that we saw in that payload. So based on what filters we find, we're going to build up this query. And here we've got our revamped search trade site function. And the first thing that I'm going to do is I'm going to change this client to include a user agent. A user agent is like a name tag for our requests. And I happen to know that the trade site will actually reject our requests if we don't include this. And you can see the editor has already figured out what I'm trying to do here. So I'm just going to remove this kind of crazy looking user agent and we'll say chiseled trade tool. And here we've got that first request URL. We can see that it is making a post, and that function we just looked at, build trade query, that is getting included in this request. And then from the response, we're taking 10 of those result IDs and we're going to stick them in the URL of this second request separated by commas. And finally, the response from that will parse into things like price, seller, item stats. And this all looks pretty good. Let's take a look at the cargo file. And Claude wants us to add these two dependencies. I think we're actually using both of these this time, but I don't recognize this Rust ls TLS stuff. And I think that Claude's trying to sneak some more garbage in. So we'll go ahead and remove that. And now we'll run it. We'll put in the item text for our boots again, click parse item. And it looks like we've got some new filters. Cool. Evasion rating, rune sockets. And now the moment of truth. Let's click search. Whoa, it works. We've got some search results from the trade site. But it looks like we got a result back that doesn't have lightning res or movement speed on it. And those were included in our filters. All right, so we've got a bug to fix. We'll need to look into that later. But this is still a big step. Our trade tool can search the trade site. Cool. So let's make another checkpoint. Trade site search done. And let's keep cruising. So now that we've got a bug, it's a good time to talk about debugging with AI. So what are we looking at here? We've got our AI code editor, in this case cursor, and it has some panels, files, prompt, terminal, and our AI model, Claude in this case, is watching over all of that. So let's walk through what just happened. We ran a command in the terminal to start up our app, npm run Tauri dev. And once our app was running, we stuck some item text in there. That got turned into trade site filters. That got turned into a query. And then finally, we got some search results. And it's at this point we noticed we've got a bug. We said to filter for boots with movement speed, and we got back some boots without movement speed. So naturally at this point we could say in a prompt, there's a bug where search results aren't being filtered by the movement speed filter. And the problem with this is that Claude can't see our running app. It doesn't know what item text we put in, and it can't see the filters, the query, or the search results. So it's going to look through what it can see, which is our source code, and it's going to do its best to come up with a fix. And if that doesn't actually fix the problem, now you might be tempted to say, that didn't fix it. Please try again. And so it tries again, and maybe that doesn't work either. And now what? It's at this point that you might just get stuck. And it's because Claude is at such a big disadvantage here. Interacting with our running app is such a goldmine of troubleshooting data, and it just doesn't have access to that information. But there's actually a really easy solution. We can just add some log statements to our code, run our app again to generate those logs, and then this time in our prompt, we're going to add those logs to help compensate for this blind spot. And I'm pretty sure the AI models will eventually gain this kind of visibility as the tools get better. But even then, I think that as a general concept, it's useful to think about what blind spots exist for your AI assistant and how you can fill in those blind spots to get better results. All right, so let's try this out. Let's open up lib.rs, which is our Rust backend, and let's scroll down to a spot where we can log the filters and the query. Right here looks good, so we'll log the filters and the query. Easy. Next, we'll run our app, and we'll reproduce the bug. So we'll stick in our item text, click parse item, scroll down a bit, click search trade. Here we've got a result with no movement speed. And now we've got some logs to share with Claude. We'll click add to chat, and now those logs are attached to this prompt. And we could look through the logs and try to find the bug ourselves. In fact, I'd recommend that, but I also want to show you that even if you can't find the bug yourself, this is a way that Claude might find it for you. So in our prompt, we'll say, there's a bug where search results aren't being filtered by the movement speed filter. I added some log statements to log the filter and the query. I reproduced the bug and captured the log output. Could you find and fix the bug? And we'll also include our item text. Now let's take a look at the fix. It looks like here we're taking the stat, splitting it by white space, and then looking at every word, removing a leading plus sign, removing a trailing percentage sign, and then trying to turn it into a number. So before we weren't trimming the trailing percent, and so 20% wasn't being parsed into a number. Nice, I think Claude fixed it. So let's run our app again and take a look. So we'll stick in our item text, click parse item, scroll down a bit, click search trade. And yeah, it looks like all of our results now have movement speed, lightning res, and life regen. Awesome. Let's go ahead and make another checkpoint. We'll call this one Fixed a Bug. Nice. Okay, we've made some good progress, but at this point, our Rust backend is getting to be a little crazy. It's over 500 lines long, and there's some Tauri stuff in here, some trade site stuff in here, some item text parsing, a whole bunch of structs, and it's kind of all just in one big pile. And this is a problem because this is pretty close to the starting point of our app. So if somebody like a coworker or a contributor, or even you, the author, 6 months later comes back and tries to understand this, this is probably where you'd start. You'd go to main.rs, you'd follow this reference, and you'd end up right here. So ideally, this file would read kind of like a table of contents, and right now it does not. So later on, we'll get really organized with some design patterns, but for now, we're just gonna make 2 new files, item text and trade site. And at this point, you could ask Claude to move all this stuff into its right place, but the problem with that is that it might move and change things in the same step, and I don't want to have to look out for that. Plus, it's something that might make us a little bit more comfortable and confident with Rust as a programming language. So this is good practice, and it kind of keeps us in the driver's seat. So we'll split this to the right, and the first thing we'll move over is this trade site filter struct, and we'll grab our mapping. And we'll grab this parse item text function. And we don't need this to be async, but we do need it to be public, so we'll change that. And we'll change the function name to be toTradeSiteFilters. And then in here, we'll just call item text toTradeSiteFilters. Cool. We'll also add our imports here, tab complete that. And now we'll move over our trade site file, grab the rest of these structs, drop those in there, move over this helper function, and the search trade site function. This one does need to be async, and it also needs to be public. And same thing, we'll just reference that in here. Fix the imports in this one as well. Save our files. And we don't need these imports anymore, but we do need to import our 2 new files, and we need to import the structs. And here we've got some errors. Let's check out what that's about. It says field ID of trade site filter is private. And it looks like we get that for a couple different fields. So all we have to do there is come over to this struct and make these public. And all that goes away. We'll go ahead and close these files. And I don't really like redundant comments, so we're going to delete those. And look at that, lib.rs is now less than 30 lines long, and it does kind of read like a table of contents. We've got our Tauri setup, and we know that item text parsing stuff is over here, and trade site stuff is over here. And now I feel way more confident that if I had to come back to this in 6 months, I'd have a much easier time figuring out what's going on. And at this point, a sensible thing to do would be to run our app to make sure everything still works, but that seems kind of boring, so we're not going to do that. We are going to make a new checkpoint, and we'll call this one cleaned up lib.rs. Cool. The next item on our agenda is to improve this mapping right here. So this is the mapping of the stats on our item text to the ID that gets sent to the trade site. And Path of Exile has hundreds of these stats, and they change over time. So right now we're providing this statically, but ideally we would be providing this dynamically. And we know that this mapping exists somewhere on the trade site because I can select any one of these stats. And if we look at the network activity for this request, we're going to see this ID is what gets sent to the trade site. So I searched this thing from top to bottom, and what I found was that if you go to Application, Local Storage, and scroll down to Stats, this is an exhaustive mapping of the stat on the item text to the ID that gets sent to the trade site. So now if we clear this storage, come back over to Network, clear this activity, and refresh this page, we'll see a handful of requests get made to populate that data. And if we click on Stats, and response, here we go. This is the stat that we see on the item text, and then the ID that gets sent to the trade site. So we're going to do the same thing. We're going to copy this, save it for later, come back over to headers, note the request method and the URL, and we're going to use this to ask Claude to integrate this into our trade tool. Okay, time to make this prompt. We'll say, we need a more extensive way to map item text stats to trade site IDs, and also let's include the specific reference to where that's happening right now. I found a request we can make to get a full mapping dynamically. Make sure to account for rune stats differently than explicit stats since they're different categories in the mapping. Let's pass the mapping into two trade site filters as a dependency. And trade site logic should be in tradesite.rs and consistent with how we interact with the trade site in other requests. And finally, we'll ask for one more thing. We'll say, let's also make a unit test for two trade site filters to make sure our parsing logic continues to work for the filters that we support. Run the test with cargo test to make sure it passes and use the following item text as an input. And now we'll also include the request URL, the request method, and the response. Let's see what Claude comes up with. And it's review time. Let's start with lib.rs, and we can see that we're grabbing those mappings and passing them into this function as a dependency. Exactly what we asked for. Perfect. This isn't totally ideal because this means that every time we parse some item text, we'll be fetching these mappings over and over, but we'll address that later. A couple other things. I don't like these redundant comments, so we're going to delete those. And I think that this reads a little bit better if we prefix it with our trade site file name. Nice. Next, let's look at itemtext.rs. And here we can see we're importing the stat mapping struct, blowing away the old mapping, passing it into our two trade site filters function. And our parsing hasn't changed that much. We can see that we're handling rune stats and explicit stats separately, which is great. And the fact that we have a passing test means that we don't have to scrutinize this too closely. And right here, I want to fix something real quick. This is something that I noticed the last time we ran our app. I noticed that for stat filters, the name and the value are the same thing, and it looks kind of goofy to show them side by side like that. So I'm going to change the name to instead either be rune stat or explicit stat, depending on what kind it is. And here's our test. So first off, we set up like a fake mapping that just includes the stats that we care about. And then we pass in the item text and that fake mapping into our two trade site filters function. And we make sure that all of the filters that come out the other end are what we would expect. So why do we make this test? 3 reasons. First reason is that up until now, we were making sure this part of the app works by manually running our app, pasting this item text in, and then verifying with our eyeballs that the right filters showed up. I get sick of doing that pretty fast, and so this automates that. Let's make sure it works. We'll go into the Tauri folder and run cargo test. And here you can see that it found and ran our test, and the green OK means that it passed. So if I were to change one of these values to something else that we don't expect on the filter and run the test again, now we see it failed. Missing rune lightning resistance filter. So now we can see that something is broken without having to check manually. Cool. Second reason we made this test is it gives us coverage. Basically, if there's a bug somewhere in our app, running this test is going to give us an idea of where that bug could possibly be. So the more coverage you have, the fewer places that bugs can hide from you. And now if you or a coworker or a contributor breaks this part of the app, you're a lot more likely to notice. The third reason we made this test is that this is a tool that can give our AI assistant more context. So before we talked about how Claude can't see our running app and the values of things like item text, filters, queries, stuff like that, but Claude knows how to run a test. So this is a way that it can see what happens when our app is running. Okay, last file to review, tradesite.rs. And we've got some new structs based on the response data that we provided. Looks good. Here's our request URL. We can see that it's a GET. And we do a little bit of parsing before we return those mappings. And this part down here surprised me. So we're in our build trade query function, and previously we were only processing stat filters that began with explicit. So that means we were ignoring stat filters that start with rune. And I knew about this bug and I was saving it because I wanted to use it to illustrate how test coverage can help us narrow down where a bug is. We're going to notice the bug, realize that our test passing means that the bug must be after we create our filters, but Claude noticed and fixed this without us even asking. So I'm a little annoyed that I don't get to use the bug to illustrate a point, but I gotta admit, I'm also kind of impressed. It's kind of cool that it found and fixed this. So let's run our app real quick. We'll put in our item text, scroll down a bit. And this looks much better. So now let's say, show me boots with lightning res as a rune stat, movement speed as an explicit stat, and we'll take these other filters off. And this is looking good. We've got lightning resistance as a rune stat, movement speed as an explicit stat. Cool, looks good. And now we'll make another checkpoint. We'll call it fetch stat ID mappings. Nice. Next up, let's set up our hotkey. I've got our original design here where we hover over an item in the game, press the hotkey, convert the item details into a list of trade site filters, and then pop up the front end with the filters. We skipped the hotkey in our prototype because we wanted to build this up incrementally, and the hotkey was kind of a lot of complexity up front, but now we're ready for it. So brief little recap. If we hover over an item in Path of Exile and press Ctrl+C, the item text for that item gets put on the clipboard. So with that in mind, let's take a look at this hotkey stuff in more detail. The user hovers over an item, presses the hotkey, and then we're going to simulate a Ctrl+C keystroke. That's going to put the item text on the clipboard, so we'll read the clipboard, and then we'll parse the item text the same way we have been, pop up the front end, show those filters. But there is a problem with this design. The user might already have something on their clipboard, and if they do, we're going to clobber that. But that's an easy fix. We'll just read the original clipboard contents, save that off to the side, send our Ctrl+C, read the clipboard with the item text, restore the original clipboard contents, parse the item text, pop up the front end, display the filters. Nice. So here I'm looking at the Tauri docs for global shortcut and clipboard, and they've got these really awesome examples that we can use. So you could just give your AI assistant this link or ask it to find documentation, but I found that nothing beats just copy pasting a solid example directly into the prompt. So that's what we're going to do. We're going to copy this one in, and for the clipboard docs, we're going to do the same thing. We're going to copy this in. Okay, let's do this prompt. Let's use a hotkey to kick off our trade tool with the following flow. Step 1, user hovers over an item in Path of Exile 2. Step 2, user presses the Ctrl+D hotkey. Step 3, user's clipboard contents are saved. Step 4, Ctrl+C keystroke is sent to Windows. Step 5, item text is read from the user's clipboard. Step 6, user's original clipboard contents are restored. Step 7, item text is parsed with our toTradeSite filters function. And step 8, our app window is popped up with the filters. And we'll also say we won't need the item text input in page.svelte anymore. And our hotkey implementation should follow this exact example from the Tauri v2 docs. And our clipboard implementation should follow this exact example from the Tauri v2 docs. And let's go. All right, let's check this out. Starting with lib.rs, we've got some new imports. And here's how we're sending a Ctrl+C. So it looks like we got some keyboard events. Press Ctrl, press C, release Control. Makes sense. Then we've got config not Windows. And it says for non-Windows platforms, we'll just wait a moment. We're not doing that. And we've also got our old parse item text Tauri command. I don't think we need this anymore. It was tied to the item text input box on the front end, and now we're using the hotkey. So I'm going to snip this too. Here's our new handle hotkey function. So we back up the clipboard, send the Ctrl+C, wait a sec, read the item text from the clipboard, make sure it's not empty, restore the old item text, parse the item text, pop up the front end, return the filters. Nice. And I don't mind having these step-by-step comments in a long function like this, but the inconsistent step numbers are kind of throwing me off, so we're going to get rid of those. And here's where we're setting up our new hotkey. This looks really similar to the official docs, and that's what we asked for, so that's great. And it looks like we send either the filters or an error to the front end. Cool. Down here, we got rid of this parse item text command, so we'll delete that. And I don't think handle hotkey flow actually needs to be a Tauri command either. If you remember a while ago, we looked at this and it said, creates a handler that allows commands to be called from JavaScript with invoke. We're not doing that with handle hotkey flow. We're actually calling it from the backend directly. So we'll snip that as well. And we'll remove this command annotation. I think Claude just got confused. So lib.rs is looking a little bit crazy again. I don't feel like cleaning it up right now, but I promise we will come back and clean this up later. And next up, page.svelte. Now we've got a TypeScript struct, great. And sure enough, here we can see that parse item text function being removed, the one that was using invoke. And instead we got two new listeners. One's listening for filters and one's listening for an error. Looks like Claude also fixed some TypeScript errors, love that. Here's the item text input box being removed. So here, if we're waiting for the hotkey to be pressed, we show some instructions. And if the hotkey does get pressed, we render the rest of the form. So it looks like the form didn't actually change that much. It just got scooted forward a little bit because of the if statement. And we've got a button to reset the form now. Cool. And the rest of this is just style stuff. So now we'll look at the Tauri configuration file. I don't know why I messed with this, but while we're in here, we might as well change it up a little bit. So for product name, we'll call this chiseled course. Identifier, we'll do chiseledcourse.makestuffwithme.com. And I changed the size of our window as well as the title. So again, we'll call this the Make Stuff With Me chiseled course. And we'll have to see how this new size looks. And finally, we'll look at our cargo file. These all look good, but this review wouldn't be complete without Claude trying to sneak some garbage in. I don't know what WinCon is, and I don't remember seeing it anywhere, so we're just going to get rid of that. And now we try it out. Oh, look at how huge it is. I have no idea why I changed that. Anyway, these instructions are kind of nice. So now let's pull up p.o.e 2. So we'll hover over these boots, press the hotkey, and it works. So this is pretty cool. We don't have a whole lot of bells and whistles, but the features that we do have, in my opinion, are the heart of a trade tool. You can get to it without tabbing out of the game. We support a bunch of filters, including a bunch of stats dynamically, and we search the trade site for live results. We still need to clean it up a bit and we need to deploy it, but this is a huge milestone. So let's make another checkpoint and we'll call it hotkey done. Nice. All right, this part I'm really excited about. We're going to use some design patterns, specifically dependency injection and error propagation. Both of these sound fancy, but they're actually super simple and super helpful. Let's start with dependency injection. And I think the best way to explain dependency injection is to first show you one of the problems that it solves. So again, let's imagine that we come back to this 6 months later, we don't remember anything, and we're trying to understand. So we start with main.rs, and we follow this reference, and we end up here in lib.rs in this run method. And we can see that we're doing some Tauri setup stuff. We can see we create a shortcut. And then we can see that when the shortcut is pressed, we call this handle hotkey flow function. That returns some filters, and we emit those filters to the front end. And we just skipped over a bunch of the building blocks of our app. And if we want to learn more, we have to follow this reference, dig into this function a little bit, and we can see, oh, handle hotkey flow depends on this item text to trade site filters function, and that depends on a stat mapping. And where does the stat mapping come from? If we follow that reference, we can see, oh, fetch stat mappings depends on an HTTP client. And at this point, we have a more complete picture of our app, but we kind of had to dig for it. And dependency injection says, hey, instead of burying our dependencies in the guts of our app, what if we created them up front and passed them down? So let's see what that would look like. For fetch stat mappings, we'll pass in a client instead of creating it. And we'll see that broke this function here. It's now expecting a client. And a client is a really common dependency, but a dependency can also be data like it is here with our stat mappings. And a dependency can also be a function, which is what I think makes the most sense here. So we'll get rid of these two lines and we'll come up with a new function name, item text to trade site filters. And we'll pass that in as a dependency to this handle hotkey flow function. And now that nothing in this function is async, we don't need the function to be async anymore either. And finally, back down in our run method, we can start to stitch this together. But first, let's create a little helper function to create an HTTP client. Then we'll create our client and we'll fetch our stat mappings. You can see we got some red squiggles here. If we hover over that, it says await is used inside non-async closure. So all we need to do to fix that is use a blocking async runtime. And next up, let's make a new function right here that takes item text and returns either trait site filters or an error. And we'll use our existing item text to trait site filters function and pass in that stat mappings that we got. So now when our app starts up, we'll get this stat mapping once, we create this function, and no matter how many times we call this function, we won't have to fetch that stat mappings over and over again. Next up, we want to pass that function into our handle hotkey flow function as a dependency. And now that this function isn't async anymore, we don't need this async runtime. And since we don't care about this released shortcut state, I'm also going to simplify this a little bit. And this is already looking much better. Let's also give the same treatment to the search trait site function. And we'll also give this hotkey stuff a home. So we'll make a new file. We'll call it hotkey.rs. We'll move it to the right. And then we'll copy over our handle hotkey flow function. We'll make it public. We'll copy over this control C stuff. And we'll fix our imports. We'll import it in lib.rs. And we'll reference that here. Easy. Okay, let's take a breath and see what all that got us. So now in our Tauri run method, we can see we do some Tauri setup stuff. We create an HTTP client. We use that to get some stat mappings. We use those combined with item text to get some trait site filters. We create a shortcut, and then we trigger handle hotkey flow, which uses that item text to trait site filters function. We return some filters, emit them to the front end. And then we can see we also register the search trait site function, which uses those filters and an HTTP client to get back some trait items. And that's all spelled out up front in our lib.rs file. I remember I first learned about dependency injection as a tool to get more control over my tests, and it is great for that. For example, you could pass in an HTTP client that always times out, and you could test how your app reacts to that. Super useful, super important. But as I used it more, the thing that really made me fall in love with this pattern is that it encourages you to show these building blocks up front, and in my opinion, really improves the composition and readability of an app. Okay, now let's talk about error propagation. In a way, dependency injection and error propagation are two sides of the same coin. Dependency injection says, let's pass our dependencies down, and error propagation says, let's pass our errors up. So the idea is that anything that can error should pass that error all the way up the chain as far as it can. And thankfully, we're already using that pattern all over our app, and that's partially thanks to Rust. Rust has this built-in result type meant for returning errors, and Rust also has this question mark operator, which will immediately return an error. It's even described in the Rust docs as literally error propagation. Love that. But there is a problem here. If this setup function returns an error, the error message will show up in the terminal if we run our app from the terminal, but our users aren't going to run this from the terminal. They're going to run it as a regular Windows app, and by default, Tauri won't show them the error message. The app will just close. So imagine you download this trade tool, you launch it, and it immediately closes without any indication of what happened. That's not an acceptable user experience. So we're going to install the Tauri dialog plugin, and we'll add that to our Tauri build step. And we'll make a little function that'll pop up our error message. And then instead of this question mark operator, we'll use unwrap or else. And what this does for us is we either get the client back, or if there's an error, we'll show the error to the user and then shut down the app. And we'll do the same thing when we fetch our stat mappings. And the reason that we shut down here is because these are what you call fatal errors, meaning that if our app can't get a client or these stat mappings, nothing else after that's going to work. So the best we can do is tell the user what happened and shut her down. Okay, much better. So with these two patterns, we get to see our dependencies up front and our errors up front. Very cool. A couple more cool things about these patterns. These are some of the most commonly used patterns. So that means if you're reading somebody else's code or they're reading your code and it's using these patterns, immediately you're closer to understanding each other. And these patterns apply to pretty much every programming language. And in my opinion, that makes them even more worth learning and using. So with all that said, let's make a new checkpoint and we'll call it dependency injection and error propagation done. Nice. Okay, so next up, we're going to release our app and set up auto updates. And we will go into each part of this in detail. But before we do that, there's kind of a lot of moving parts here. So first, I want to just quickly go over how all this is glued up at a high level. So here we've got our computer, github.com, and our app. Our computer has our Git repo on it with our source code. And from a terminal, if we run git push tag, that triggers a workflow on GitHub. And that workflow creates our installer, signs it with a private key that we'll configure as a GitHub secret, and then publishes that as a new release. And for our app, we're going to be using the Tauri updater plugin. And the way that works under the hood is at first it asks, where do I even look for an update? And for that, it looks in our Tauri configuration file for an endpoint. We're going to configure that endpoint to be the URL for our latest GitHub release. If it finds a newer version there, it downloads that version, validates it with a public key also in our Tauri configuration file, and then installs that version. So there is a fair amount of plumbing here, but the nice thing is that once it's all set up, all we have to do is push a tag and the rest of this process happens automatically. Pretty cool. All right, let's set it all up. Okay, let's deploy our app. I'm here on the Tauri GitHub docs, and if I scroll down a bit, there's this example workflow that will build a Windows installer and publish it to GitHub so that people can download and install our app. So we'll get into this line by line in a second, but for now I'm just going to copy it. And then in our app, we'll make a new folder. It'll be .github. Inside of there, we'll make another new folder called workflows. And inside of that, we'll make a new file called release.yaml. And we'll paste that workflow. And we're going to simplify this quite a bit. Instead of triggering this when we push to the release branch, we're going to trigger this when we have a tag that starts with V for version. And we only care about the Windows platform, so we're going to delete these other ones. This line here checks out our source code, and we don't care about this Ubuntu specific step. We're going to get rid of this caching line when we set up Node, just to keep things simple. And this section here will install Rust, and we can delete this bottom part because it's specific to Mac. And we'll delete this Rust cache step, again, just to keep things simple. And here we're using npm. So instead of doing yarn install, we'll cd into our app folder and do an npm install. And here's the step that actually creates our Windows installer. So we're going to add a project path, app. And for a tag name and release name, we're going to change this to github.refname, which will be the name of our tag. And finally, we'll change release draft to false so that we don't have to mess with drafts. And now just to summarize, this workflow will trigger when we push a tag starting with V for version. We'll check out our source code. We'll set up Node. We'll set up Rust. We'll do an npm install. And then we'll create and publish a Windows installer. So now we'll make a new checkpoint. We'll call this release workflow done. And now we need to set up a repo on GitHub. So here I'm logged into GitHub. I'm going to come up to the right here and click this plus sign and click new repository. We'll call this the chiseled course. It'll be public. We'll click create repository. And down here it says push an existing repository from the command line. That's what we want to do. So we'll copy this first line. And then we'll do git push origin main. And now if we refresh, we'll see our source code up on GitHub. Nice. So now we want to trigger this workflow. So we're going to come over to our cargo file. We'll change this version to be 1.0. We'll make a new checkpoint called v1.0.0. We'll push that, and then we'll create a tag, v1.0.0, and then we'll push that tag. And now if we refresh, we'll see this orange dot here. If I click that, and then click details, we get to see our running workflow. Cool. And our job completed in a little under 8 minutes. And if we come back to the repo homepage and click releases, that workflow created this release and published these installers. So now anybody can download and install our app using either one of these installation files. Pretty cool. And we can release a new version anytime we want, just by updating the version, creating a tag, and pushing it. Awesome. There is a slight problem though. In order to get an update, our users would have to come back to our GitHub repo and download it manually. It'd be way better if our users could get the latest version automatically through our app. And the good news is, it's pretty easy to set that up too. I'm on the Tauri docs for the updater plugin, and there's a lot in here, but I'm basically going to break it down into 5 small steps. Step 1, in our terminal, we're going to run the npm run Tauri signer generate command. And we won't enter a password. And what that did is generate a private key and a public key. We're going to save both of these for later. And these are basically used together to authenticate our updates. The details of how this works is some brain-melting cryptography stuff. We're just going to cover how it's used in practice. So step 2, we'll add the private key as a secret to our repo. So here's our repo. We'll go to Settings, Secrets and Variables, Actions, New Repository Secret. The secret name will be Tauri signing private key. We'll stick our private key in here. And now we'll come over to our release.yaml, and we're going to add 2 things. We'll add the new secret under env, and at the bottom here, we're going to add include updater JSON true. We're going to come over to our Tauri configuration file, tauri.conf.json, and I'm going to copy this in from the docs, and we'll clean this up a little bit. This will be make stuff with me chiseled course, and this will be our public key. And while we're in here, we're also going to snip this version so that it uses our cargo files version instead. That way we just have one less file to update. And finally, step 5, we'll update lib.rs to check for a new version. So first off there, we'll add the plugin to our cargo file. We'll add it as a build step. And we're going to add a new function straight from the docs. And we're going to clean this up a lot. We don't care about things like chunk length or how many bytes we've downloaded. And if we do find an update, we'll pop up a little message. And let's also rename this to just show dialog, since it doesn't have to be an error. And we'll use the blocking runtime again here. We could run it in the background, but if we get an update, I don't want our app to pop up later in the background. And let's make a new checkpoint. We'll call it auto update done. And we'll also make a new version. So we'll call this 1.1.0. And while we're in here, we'll also change our app name, the description, the author. And now we'll bump the version. We'll push that. We'll create a new tag. And we'll push that too. And now back in our repo, we can see that new version's cooking. Nice. So now we're going to make sure that all of that is working. Let's make another version with a few minor changes, and we'll see if we can auto update to that version. For a change, in the front end, there's a few headings that are kind of taking up a lot of space, and I don't think that they're necessary. Like this one here, Path of Exile 2 trade tool. We can get rid of that. And this one here, select trade filters. And this one here, search results. We can get rid of these, and I think that people will still know what to do. And let's also make the window size something more reasonable. And now let's make another checkpoint. We'll call it snip front end headings. And we'll also bump the version. We'll do 1.2.0. We'll push those up. And we'll also make our tag. And we'll push that up as well. And now we wait for this workflow to finish. And now we're ready to try this out. So v1.1.0 supports automatic updates, and version 1.2.0 got rid of those headers and changed the window size. So we'll download and install the older version. We'll run that. The huge window opens, and here we go. It says update found installing. Ooh, and here we can see the correct window size. And here we've got our trusty boots. Let's press the hotkey. Nice, no headers. That tells us that we successfully automatically updated to the most recent version. Awesome. And that concludes this course. We did it. We built the Path of Exile 2 trade tool from scratch. We covered a ton of ground. We came up with a design. We built a prototype. We got a ton out of our AI assistant. We used the heck out of the Tauri framework. We figured out the trade site API. We did some debugging. We made a test. We used some design patterns. We deployed it. Awesome. Thank you so much for watching. I'm happiest when I'm building stuff and sharing that with people, and your support means that I get to do that. So again, thank you so much. Subscribe for more, and hopefully I'll see you in the next one. Bye.